map, filter, reduce, map, filter, reduce. All right, these are some of my favorite methods in a lot of different programming languages. So let's talk about how to use iterators in Rust. My name is Ricky, and welcome to the Dev Method. Iterators are discussed in Chapter 13, Section 2 of the Rust programming book. So the whole point of iterators is to traverse over a series of items and do something with those items. Iterators in Rust are lazy, and they don't actually do anything until there's some sort of execution at the end. So when we're making these calls to these iterators, it's just like building up a bunch of different instructions and waiting for it to be executed later. So let's look at our first bit of code of iterators. So here we have a very simple vector, line 7. It's named v1, and it just has 3 numbers. It's got 1, 2, and 3. And here's our iterator. So vector here, just dot iter, creates us an iterator. So what does that type look like? Well, it looks like so. It says iter I32. Just like this. Iter I32. That's its type. Now the whole idea here is that it doesn't do anything. So we actually haven't processed anything. We have an iterator ready to go, but we haven't done anything with it. So now I've commented out the code that I had from before, and let's just take a look at what this could possibly be like without iterators. So here we have a for loop. We're using while, and we want to go through the whole series of these feelings of the dark side. So it's fear, anger, hate, suffering. So it ends with that. Now, if we were to start on line 13 here, this is kind of like the beginning of the iterator part that we're going to be looking at. So we need some sort of state or something to track where we are as we're iterating through all the different items. So that's what we're going to use for I. And as long as I is no greater than the total count or length of the vector dark side, then we should be able to access these elements or these items without having any issues. So for example, what we're doing here is we're doing that loop. So this is like our initialization of that loop. This is our condition of whether we continue on with the loop. And this is what we do after every single iteration of the loop. So we just increment I by 1. And then this line 15, this is where the real special stuff is. This is the stuff that will change in all different use cases in all different programs. So here we're just simply printing out what it is as item here, but then also its index. So let's run this and see what it looks like. So I'm going to do cargo run. All right, here it goes. So this is our output. So first index, fear, next index, anger, and so on. So here's the problem with this type of for loop programming is that it's very easy to make mistakes. There's already a lot going on in your programs. So why have to I guess reinvent the wheel, so to speak, of this initialization, the condition, the final step. And what if we could just get to this middle part here and not worry about the rest? And we don't want to make mistakes. There's other complicated things we're going to want to do other than print this out. Like what if we wanted to I don't know, add something to all these strings into a brand new vector and do something with that vector. So use cases can be astronomical. So now let's look at the same code, but this time we want to use iterators. So we're going to use a for in loop here. So here we have our iterator just like before, and so far doesn't do anything. But now we have the item that we want out of each one. So this is the same exact thing as we had in the previous code, except we don't have to track what I is. We don't have to track the length of this vector anymore. And we don't have to remember to increase I every time we're done iterating through the loop. So all we have to do is just print out the item. So it's pretty simple. That's all we really wanted to do in the first place. So here's our output from before. Let's run it again. There it is. Nice. So let's stop for a second and actually look at what an iterator is in Rust. So iterator is actually a trait in Rust. So here on line 6, that's how it's called, iterator. Then we have a type, and this is the key thing we want to look at first, is this next, this concept of the next method. Let me help explain some of the parts of this because we might not have seen this before in Rust with traits. So type is known as like an associated type. We don't know what the actual concrete type is. We don't know if it's a string, if it's some sort of number, an I32, a use size, a custom struct that we've had or made. So that is going to be the variable type in this trait. So because of that, if we want to access it, this is the other little thing that might be different too, is this capital S self. So this is how we can refer then to the type, because it's really just scoped to just this iterator. So then we use the : and then item. And so what next is doing is it says, okay, this is a method that you call, and we're going to return one of these items that is in your series or in your collection. And it might be there or it might not be there. So that's why it returns an option. And so now if you want to create your own iterator, this is at least one of the stepping stones to understanding that concept. So next, let's directly use the next method on an iterator. So here I just wrote a simple test in my lib.rs file, and I have that same vector as we've been using before, the 1, 2, and 3. I have the iterator, and now I actually want to call next on it, and I'm making some assertions in my test. I just want to see if we have 1, if we have 2, if we have 3, what we are getting. Now the iterator, when we're calling next, actually is returning back a reference to the items. So you don't actually own the items. They're actually owned by the vector here. So that's why we get the reference to it. And so let's just run this code and see if it passed the test. I do cargo test. All right, it passed. And so if we just step through this real quickly, just the first time we call next, see this iterator is actually mutating itself internally. So it knows, okay, I've already given you the first element or the first item. Now, if you call next again, then in the next sequence of code, then you're actually going to get the next item, which is this one here. But then that's kind of like expired, right? So now if we call next again, we're going to get that third. Any subsequent calls after that, since we've expired all of the items in this series, we will just get none. So if we want to restart back at 1, we have to actually create a new iterator. So here's another example. This time we're actually using string slices. So if you look at the type of this is a vector, and then it's got the ampersand. That's our string slice, str. And this is the way that we're going to get some of the items out of that. I'm going to run this, and you can see what it looks like. But the first thing I want to point out here is that we're actually using something a little bit different. We're now going to take ownership of the items. So that's where we have into iterator. So into iterator, very similar. We're going to get a lot of the same capabilities and methods, but we're slightly changing the approach of how we do it. So we're going to have ownership of these items after every time there's a next. So that's why we have here some fear. Let's run this. Let's do the first one here. Cargo test. Here it goes. They pass. So iter gave us access to immutable references to items. There's also ways to access mutable references to these items, and that is with iter mute. So iter mute on line 10, again, does something just slightly different. Now we're getting mutable accesses to these items. All right, so far we've just done like the for loop. We've done the next, just calling those in a series. Let's take it a step further. Let's talk about methods that consume the iterator. These methods are known as consuming adapters. So here's this example on the vector iterator. So we iterate right here, line 10. Now, instead of a for loop, we already know what the operation needs to be. So we have this nice, convenient sum. So it consumes all of the elements and makes a total of them, so adds them all up, 2 plus 1 is 3, 3 plus 3 is 6. So that's what this total is going to be at the very end. Let's run this and make sure it works. Cargo test. Nice. It was all passing. Now there are also methods that produce other iterators. So let's look at this example. Line 7, we have our regular iterator. I've already annotated the type explicitly here. Now we have iterator, but we're going to use map. Yes, one of my favorite. So map, over all of them, going to return a new kind of item in place of that array. Now it doesn't replace the values that are in v1, but it allows us then to create a brand new vector if we wanted to, and in the same order, we actually now have a new value. Well, maybe we have a new value. This closure here, or this anonymous function, could transform the value. So here we are doing that. We're saying, take that value, whatever place we are. So like in the first time, it would be 1. So 1 plus 1, it'll be 2. Then here, it'll be 2. So 2 plus 1, that'll be 3. This will then be 3. So then 3 plus 1 will be 4. That will be 4. So that's the idea. But what is the value of x? So let's take a look at that. So x here is actually another iterator. So it's map, capital M map. And it's got some generics in there. It's actually kind of annotating some of these things for us. It's saying, well, originally we started with a iterator of I32. At least that was the type of the item. But then we said, what is the transform? And it's something that we get a reference, a immutable reference to that item, which is that I32. And then we have a brand new value being returned, which is, again, of type I32. I guess if we wanted to, we could have said it's of type string. So we could say whatever this value is to string. And now this type would say, okay, it's a reference to that immutable item, I32, but we're returning a totally new type, string. It's the idea. So now in line 12, if we want to get like a new vector ourselves, like we have the instructions ready to go, but now we need to execute on it. So that's where we use collect. It's really helpful to do this. Now there is a little sticking point here. We don't actually know what the type is of y, so we need to be more explicit about it here. So I'm just going to say vec of I32. That's what I expect. So now we know what I is, and we can continue to use it within the execution of our program. So another cool thing that we could do is we could chain a lot of these methods together. So here I'm going to actually do that after I do the map, I'm going to do a filter. It's another cool one. So filter, we're going to have, again, x. We're going to say if x is greater than 2. So we're going to map over all the elements, but then only take the things that are greater than 2. Now we do have a slight issue here. So first we were doing something that was a plus, but now we have the greater than. And the way we're going to fix this is we're just going to dereference x there. All right, so now what is x? So now it is actually a capital F filter, so that's another type of iterator. But then its original iterator was a map. This is where the types get a little confusing. So the type annotation gets really long really fast, right? So again, we want x and collect. So I have that on line y. Now what is this type? Well, again, I already know it's going to be I32. So there we are, we have y ready to go. Now I don't have to do it on 2 separate lines. Typically you'd see it here. There we go, put in the collect. Then we don't collect again. Now let me take away this type and let's look a little bit deeper into the issue that we actually have. So here it's saying there's some sort of like Rust compiler issue. And why can't it just figure out that I want to collect these things together and make an I32? Well, first let's start with cargo run and see the issue. So cargo run. All right, so yeah, it's saying consider using a type. That's really it. That's all it says. So let's try this on the command line. let's explain what this error actually means. I'm going to make this a little bit bigger for us so we can read together. All right, so the compiler could not infer a type and ask for a type annotation. Okay, yes, that's correct. So here's another example of a string slice, get the characters, reverse them, and then collect them, right? So this error indicates that the type inference did not result in one unique possible type, and extra information is required. In most cases, this can be provided by adding a type annotation. Sometimes you need to specify a generic type parameter manually. So in this case, that is one of them. And look at this. So it says a common example is when you use collect method on an iterator. It has a generic type parameter with a from iterator bound. Haven't really learned or looked at that yet. Which for a char iterator is implemented by vector and string, among others. Consider following snippet that reverses the characters in the string. So here it is. Here's a little snippet that we have. So here it is. What we've been doing to resolve this issue is just be explicit about the type and move on. Also, this is another option here too. You can just put this like underscore here. So let me show you what that looks like. So just do this, vec underscore, and that satisfies it as well. And then it knows that it's an I32. So that's pretty cool. Another thing you could do too is actually put it right after the collect. So collect actually has a generic on its method itself. And you can specify that here. It's now on the right side of the assignment operator here, rather than on the left-hand side. I usually put it on the left-hand side, but I guess it's up to you and your team to decide how you want to do that. And if you don't want to be exactly explicit about the type, you could just use the underscore here. All right, so let's take a look at a little bit more of a real-world example and then a test for these iterators. So let me help explain the structure here. We have shoe defined on line 7. It has a size and a style. So for example, it might be like sandal or a running shoe or something like that. It can be really anything. It's just a string. Line 12, this is our function that we want to test. This is shoes in size. And what it is just given a vector of shoes and then the size, only filter out the things that equal that size. So like if we had size 10, we want to make sure that out of all the shoes that we're given, we want to keep all the shoes that are size 10 and return that in a brand new vector. See, there's that return. Look, here's our collect. If we work backwards from right to left, that's where we're getting the vector there in the collect. And we're actually using a filter, so we get the filter iterator there. But then we're actually using into iterator. So we're actually taking ownership of these items. And that is actually okay, because if you look at this function signature, we actually have ownership of shoes. So totally valid to do this. Totally makes sense. We, we're not like stealing ownership or copying variables out of here. We have complete ownership. We're good. And and then it returns it. So let's look at the snippet of code here. So here's our test. And given the input of shoes, here we have a shoe of size 10, which is a sneaker, shoe size 13, which is a sandal, and then we have a shoe of size 10 again, and that is a boot. So if we were to do a test and we want to say, okay, well, we only want to keep the shoes that are size 10, we would expect this one to be first and this one to be second. So no size 13 shoe. And that's where we have this test here. So this is our output on line 37. So we have size 10, and now we use our assert equals. So this is our output, and then this is what our expected output should equal. I'm going to run this real quick, and we're going to make sure it works. Cargo test. Nice. We did get some warnings. You might have seen the yellow squigglies, but that's just saying because we're actually not using it in the global project. That's fine. Just an example here. Thanks for watching, and if you guys want to see more videos like this, go ahead and hit the subscribe button below, or hit the thumbs up if you like the video, maybe send it to a friend. And if you just want to see when updates come, I will be posting that on Twitter, so that's the dev method, if you want to see updates of the new videos when they come out. Otherwise, I'll see you in the next video. Have a good one.